This is Professor Gavoor again. I made up a data set. From Yahoo Finance, I pulled the Dow Jones closings from December 1st. So it's a November closing in 2018, all the way through the closing on November 1, which is October closing for 2020. So I want to do three things. I want to create three different worksheets to use the same data. The first one I'm going to do DJI, Dow Jones Index, regression. And let's make it simple linear regression. Dow Jones Index MA for moving average. And Dow Jones Index exponential smoothing. Okay, there we go. So first thing I'm going to do is copy my data. Leave my raw data there, but let's go to my index here where I'm doing regression and just make the data set bigger so you can see it better. Now, what I want to do is add another column. Insert column, and let's call it month. M-O-T-H, and it's going to be this way. Let's call that month 1, and Y-M-I. So why is that? If I make that 1, is it? I want to justify it like that. Okay. And just simplify it because these dates are difficult. So I'm going to make that month 1. I'm going to make this equal to month 1 plus 1. And I see what's wrong here. It's not treating it as these are text. I want to treat these as numbers. So if I treat them as numbers, this is equal to that plus 1. And I don't want any decimal places. And maybe I will even center it so it looks easier. And then I'll copy this all the way down. So we have 24 months worth of data. That's easier for my x-axis to look at. Still a time series. I've just relabeled things. So now the first thing I want to do is plot this data. Usually when I take two adjacent columns, it assumes the X data is in the first column and the Y data in the second. So I go to Insert. And if I look at recommended charts, it gives me a number. It gives me something like this. It's not a scatter plot, but it's actually kind of a line plot. So if I want to go over here where it says quick layout, and I go here where it says f of x, this is a little Excel magic. It actually gives me the regression equation. Are you kidding me? That's wonderful. So let's make it this way. Let's say, let's go back home. Let's make that the maroon color I like. Make it bold and make it somewhat bigger. So it gives me my regression equation and it gives me titles. I don't need this because I know what it is. The dotted line is my regression line, and you can look, it kind of fits. The Dow Jones was going up, President Trump was happy. Then COVID struck, it went down, but it's come back up very nicely since then. So I can look at two linear trends. I can look at this linear trend all the way across, or I could look at this linear trend here. Maybe not using the bottom point. So this is where the art comes in. What do I want to do? I'm going to use all this data. That's what I used to get this equation. 71.324 times the month as measured by 1, 2, 3, 4, 24 and on. Times that month plus 25,383. That's where it crosses the y-axis. And maybe I want to make it only go from 15,000. So if I want to format the major axes, well, I don't want to do that, no. I want to format the axes. And I want it not to go from 0, but I want it to go from 15,000 as the base. So now it shows a little bit better. So if I want to, and you should be in the habit of labeling these things. This is month. And this is DJI closing. And this is DJI closing prices. Prices 11, 18 to 10, 20. Oh, geez, now I have a perfect graph. All right, so there I go. There's my regression. Is it good? Is it a good model? I don't know. But I can do my forecast. I can see what the forecast is. This is the actual close. This is the forecast. And how do I get the forecast? Well, I know it's equal to 71.324 times the month plus 25,383. 25,383. And it gives me to one decimal place. I really don't want it to one decimal place, so I'm going to make it no decimal places. And I calculate it all the way down. If I want to move this down and forecast 3 months out into the future, I can do that. And you can see it's going up steady. I don't have actuals there, so I can't do that. But what I can do here now is I can now get my error. I can get my absolute error. I can get error squared. I can get, and let's make this, let's wrap the text. And let's make these a little bit bigger. And let's make sure we left justify all that, make them all bold. And we're doing great here. So I have error squared, and then I can have absolute percent error. That's my APE. So what's my error? Very simple. It equals actual minus forecast. And let's make them, let's make all these, I don't need the pennies. So we can get rid of the decimal places there too. And we can get rid of the decimal places here. And notice that, oops, it's doing it economically, right? It's doing it accounting. The parentheses are negatives and the others are positive. So if I do ABS, which is take the absolute value of this, they should all be positive at that point. And I don't want to take it all the way down to here. Again, I want to make these no decimal places. But now I can do my first thing. If I take the average of these, equals AVERAGE, and I take the average, boom. I know. Leave me alone. Why does it come out to be 0? That happened the other day too. I don't like that. F2 to F26. Okay, so it comes out to here. And let's make these all oops. Let me make these all. I don't need the decimal places, so that's my, let's make it bold. And this is actually my mean absolute deviation. So it says, this is not a bad regression model, actually, because I'm explaining only 9% of the variation, but my average error is off by $1,000 on a base of 24. So that's pretty good, actually. I would be happy with this. And let's make this centered. Probably makes it better. And let me put some sort of color on that. Let's make it orange. And basically, I want to box all this in. I'll box this in. These are my forecasts into the future. And now I want to calculate my squared error. So let's just square it. So let's just say it's equal to that. Shift, so I get the caret above the 6. And then I say it's 2 for squared. And it gives me these numbers. And I just go all the way down here. And the squared error is much bigger, obviously. And if I want to say, move this over, it gives me that average, but it's like 2 million. So what does that mean? Mean squared error. That's a tough thing to read, because what does that mean? I can understand my average error here is 1,222. But now my mean squared error is 2.3 million. Interpret that for me, please. What do we mean? So let's make this yellow. And let's make that bold. And there we go. So let's do mean absolute percent error. So I take my absolute error equals absolute error, divide that by the actual, and express it as a percentage. Cancel, stop, just go away. And put percentage, and I'll make it 1 decimal place. I don't know why percentages, I can have it to 1 decimal place. So it goes down to 0 and stuff here. That's fine, get rid of it. If I copy this over, it's going to make it 0 because it's not a percentage. So if I write it as a percent and make 1. So my percent error is 4.8%. Is that good or bad? Well, you make the judgment if it's good or bad. You decide if it's good or bad. You're driving the car. You got to decide if you can live with this kind of error. If you can't live with that kind of error, then it's bad. If you think, wow, that's pretty accurate. If I can forecast it to this degree of efficiency, this within 4.8%, I'm a happy camper. So let's make that, what color should we make this one? Oh, let's use green. Okay, so there, I have done my regression analysis. See, I've committed to a line. Now, if the Dow Jones, we go into a recession or something, and it goes down to like 15,000, well, this line will not be able to predict that. That's the problem with the regression. You're committed to this line. Every month, you're counting on the Dow Jones going up $71. That's just the way it happens. So let's look at something else. And maybe I want to capture, let me capture, I'm going to make my life easier. I'm going to capture the whole thing here, okay? And copy. And I'm going to move to the moving average part. And I'm going to just say paste. I don't need this graph because we're not doing that anymore. And I don't know what my forecast is because I'm not doing that anymore. And the squared error, why is the squared error? Well, it's so big because I'm just squaring and I have no forecast. So really, I'm going to leave this all because I've done all the calculations. If I just put a new forecast in there, I should be okay. Let's use, I don't know, what do we want to call it? Let's insert. Insert. And this is moving average of months. And let's make this bold and bigger. And let's make this, are the months, we're going to take the average of 3. I don't think it really matters, but if we want to change it, we can change it. Okay, now, I can't forecast, I need 3 months of history to forecast, so I don't have history before that, so I have to give up 3 months. So let's gray these out. And that means these forecasts are all going to be zeroed out. So my first forecast, and we can make these all gray, I guess. So my first forecast is then going to be what? Equal to the average. Oh, and I should make this bigger so you can see it, sorry. Okay, so there we go. My first forecast that I can make, I need 3 months of history, so there's 3 months of actual. It's going to be equal to the average of these 3. Okay, now you see it changes all my error, absolute error, squared error, and all that. Now, the magic of Excel, I just drag this down. And I can only drag it down that far because I can only forecast 1 month into the future. But it automatically calculates my MAD as 1.1300. So it's not as good as 1200. My MSE and my MAPE are both higher than they were. So it's not reacting. I think the regression is a better model based on historical data. And the way you check out a forecast is you use historical data to do whatever calculation you're going to do and then test to see what your accuracy is. And you assume that accuracy is going to move into the future. So now let's draw three things. Let's draw a month forecast all the way down to here and insert a graph. And what do they recommend to draw? Let's do that. So what have we got here? These are my actuals. And you could see, and this is my forecast. And if I want to change this to what? I don't see any way of adding stuff. Anyways, this is, let's just call it Dow Jones Index 3-month moving average. And if I want to format the axis, does it give me a label? No, that's right. I want two arcs. That is reverse order. What else can I do? Format axis. I don't know. I used to know how to do that. I can't do it now. So I was going to add what it was, but this is a good plot. You can see how this doesn't move as much because I'm taking an average. Average has a smoothing effect. So I'm going to keep this, and I'm going to record. I'm going to go here, copy, and paste the whole thing in the exponential smoothing one. I'm going to make it bigger. And again, what I'm going to do is get rid of the forecast because I don't have a forecast yet. That's what we're going to try to determine. And I don't have a forecast there either. So, and I need a seed. You know, I don't need 3 months, so I can get rid of this. No fill. But I'm not going to use the first one, but here I'm going to put another number. I want to use 23,300. And I'm going to call that a seed. It's not part of my calculations. So I'm going to make it red. I'm just making up a forecast. I could put it 23,000 or I could put 23,300. I made it closer. Maybe I'll make it 23,000. I'm off by 323. So now, oh, gee whiz, I don't remember how to do this formula, but I have this. The formula's in here somewhere. Alpha times actual, 1 minus alpha, plus 1 minus alpha times forecast. Okay, so let me go back to my Excel. And I've got to say, this is not this, it's exponential smoothing. Exponential smoothing. Alpha equals and let's see, what do we want to make this one? Let's say alpha is equal to 0.3. Okay? So now, it says equal to alpha, and I want to put a dollar sign there because I'm not going to let that index, times this plus 1 minus alpha times that. I put the wrong number in now. I got C4, that should be C3. And there should be a dollar sign here as well. And then if I say enter, okay, now I got this, and let me copy this all the way down. And I want to copy these up too. So now I got my mate of, and I should probably look, I probably have to recalculate this. It goes from F3, it's not going from F3, it's going from F2. And this one's going from G4. Did I say 2? I meant F4. And this one goes from H4 to H26. Didn't change it much. I think when there's nothing, it doesn't calculate, doesn't use it. But now look at my graph. Now if I want to change my alpha, this is kind of cool. I can change it from 0.1. It's still not, did it change it at all? I made one up, let's make it 0.9. And let me change this to format axes. And let me make it 15,000 again. So it looks more exaggerated. Let me change it to 0.5 and see if it changes anything. It's not changing the graph. Because why? The graph is on the previous chart. It's what we're graphing here. Let me go over here and change these to format axis. And let's make this 15,000 as well. It's a little circuitous here. Sorry about that. And let me change these to, instead of F3, it's going to be F6. See if that changes anything. G6, and this would be H6. So it's 5.2. It's still 5.2. So my exponential smoothing at 5, at 0.5 is 1200. 2.5 million MSE and 4.8. What was my regression? It's pretty close to being the same. Can I improve upon it by changing my alpha? And here's what I want to do. I want to do this. I want to graph these. And I want to insert that graph. Go away. Let's make it bigger. And let's make it go down to 15,000 again. Start at 15,000 instead of 0. 15, 1, 2, 3. Okay, there we go. So there's that. Let's change my alpha to 0.9. Now you see it reacts quicker to the ups and downs. That might be the best one. It gets it down to 4.6 and a MAD of 1.77. (1.3), 1.17. So this one's probably the best. If I make it 1, it exaggerates it a little bit, but it basically makes the forecast the previous. And if I make it 0, it makes it for a flat forecast of 23 all the time. It's always a previous forecast. So it seems to want to weigh the forecast more heavily. So let's use 0.9. I thought that gave us a pretty good answer. So look what happens. If we go from 0 to 0.1, it becomes more responsive every time I do that, to 0.2, to 0.3, to 0.4, to 0.5, to 0.6, 0.7, 0.8, and then I think we decided to keep it at about 0.9. I think that's pretty good. So see how it lags here. We have it coming down and then sharply going up. But it's going to lag, so it's following the going down. And then the next one, if we look at the next one, where's my forecast? Yes. If I drag it down one more, and I include this one to be down to there, it didn't change the graph at all. Why didn't it change the graph at all? Because I have to change this one too. Sorry. Like every time I do it, it's new. I'm going to do it often. There we go. See how it comes back up now. That's we forecast in 1 month. So it's always kind of lagging a month behind. Exponential smoothing is okay, but I'd rather have it, not lag that month. But this is part of the art of forecasting. All right, that's all I've got for you. But this shows how you can do these kinds of things. And once I created the error, absolute error, and all that for this data set, and calculated the MAD, MSE, and MAPE, it was pretty much copy-paste to try exponential smoothing and to try moving average and exponential smoothing. If I was to make moving average 4, it would flatten this curve even more. If I made it 2, it would be a little bit more responsive. 2 would probably give me a better forecast here than 3. 4 would probably flatten it out and give me a worse forecast. But 3 is probably the most popular moving average. And most people don't use moving average. They tend to use exponential smoothing and try to optimize the alpha for it. Well, thank you so much. We'll talk again soon.